Proportion. Okay, in this video, we're going to talk about proportions, specifically our objective. We want to solve equations and applied problems that are proportions. All right, proportions are extremely popular. They're extremely popular method for solving applied problems because you're comparing two things, and it's a nice way to solve a whole lot of different problems. First things first, what is a proportion? A proportion is an equation that says that two ratios or two fractions, a ratio is a fraction, are equal. So here I have two ratios or two fractions, and I'm telling you that these two ratios, these two fractions are equivalent. Therefore, they form what's called a proportion. Okay? The key to proportions is what you can do with them to solve problems. And here's how it works. Proportions can be used to solve many problems because the cross products of a proportion are always equal. Okay? And let's see that here. I told you that these two fractions formed a proportion. Okay, that means that their cross products should be equal. Cross products mean we go from high down to low. We go across the equal sign. So this is going to be a product of 16 times 5. And this cross product, again across the equal sign, is going to be 4 times 20. And if we do the math here, well, 16 times 5 is 80, and 4 times 20 is also 80. So indeed, these two fractions, these two ratios, formed a proportion. Their cross products are equal. Okay, let's do some solving. We're going to do probably, 6 examples or so to see a variety of ways as to how this works. And throw in a variety of suggestions and tips. Okay, so we're going to be solving proportions. Let's just do some basic math ones first. Solve the proportion x over 4 equals 9 over 6. So we're looking for what the value of x is. And since you know it's a proportion, you know the cross products are equal, and you can use that fact to solve for x. So I'm going to rewrite the proportion. Okay, I know the cross products are equal, so this side's going to be 9 times 4, and the right side is going to be 6 times x. Normally we write the number in front of the variable. I can simplify the left side. 9 times 4 is 36, and now I can solve for x. To get x by itself, it's being multiplied by 6. We'll use the inverse operation of division. And we come up with x is equal to 6. To solve this proportion, when x is 6, these two fractions will be equivalent. Okay, let's take a look at some more examples. This will get a little bit more complicated, but the idea is the same. Okay, let's solve here we go. Let's solve the proportion. Okay, well, on one side, it's x minus 2 divided by x plus 8. And on the other side of the equal sign, the fraction is 3/5. So we got a fair amount going on here, but the idea remains the same. Okay, I'm going to first rewrite it. X minus 2 over x plus 8. And I'm telling you it's a proportion. I'm showing you that this fraction equals this fraction. Whenever you have two fractions that are equal, they form a proportion. If they form a proportion, we know their cross products are equal. Okay? This side is going to be the number 3 times the quantity x plus 8. Okay, the cross product, the numerator of this fraction times the denominator of this fraction across the equal sign. And this cross product, I'm going to write the 5 first because it tends to be what most people are used to seeing. You can multiply in any order you want, so it doesn't really matter, but it makes more sense for most people. 5 times x minus 2. So the numerator of the left times the denominator of the right. So here we are, and now we're into some basic algebra to solve for x. Generally speaking, you're looking to simplify, separate, and solve. So the left side can be simplified because it's a product. We can do the multiplication using the distributive property. Positive 3 times positive x is positive 3x. Positive 3 times positive 8 is positive 24. That the left side's been simplified. Positive 5 times positive x is positive 5x, 5 times x. And positive 5 times negative 2 is negative 10. So from here to here, we simplified. Both sides in this case had multiplication, and we did the multiplication. Now we're here. Now we need to separate. We need our variable terms on one side and our constant terms on the other. We want to separate our variables from our constants. I'm a big fan of keeping if possible, keeping my variable positive, because people lose negatives. So I'm going to subtract 3x from both sides, because that's going to give me, on the left, 2 x's. And so my variable term is positive. 3x minus 3x, of course, is 0. And on the right, I'm left with 24. And since I've now moved all of my x's over to the right in this case, I want to separate. I want to move my constant or my numbers over to the left. So I'll do that by the inverse operation of addition by adding 10 to both sides. And now I have a 34 on the left and a 2x on the right. Again, that's a 0. So from here to here, we separated. And now we have x's on one side, constants on the other. Now we need to solve for 1x. Well, this is multiplication, and we're going to use division. And of course, 2 divided by 2 is 1. That was the goal. And we have x is equal to 34 divided by 2 is 17. And so from here to here, we simply solve for x. So that gives you a little recap of some of your basic algebra skills to solve this proportion. And so when x is 17, these two fractions are equivalent. Okay, let's take a look at what that means. I'll go like this. Let's choose 17. So I have 17 minus 2 over 17 plus 8. I'll just write down 17 plus 8. Does this equal 3/5? We're checking the answer here. Well, 17 minus 2 is 15. 17 plus 8, I think, is 25. And you can see if I simplify 15 over 25, both of these sides are equal to 3/5. I could also do the cross products, and both of those, the cross products, are equal to 75. So we're just checking our answer. Let's do one more numerical example, then we'll get into a couple of applied problems. Okay, example 3. How about solve the proportion (3 over x is equal to 7). Now this tends to throw some people because they look at that and they say, well, I don't have two fractions. How can you call that a proportion if I don't have two fractions? A proportion is two fractions that are equal. And this is not a fraction, it's a whole number. Well, keep in mind, you can write any number as a fraction by simply placing it over the number 1. So I can take and copy the left side, it's already a fraction, and I can simply write 7 as 7 over 1. And now it's a fraction. And I could do that anytime, in any case I want. If I just have a number, I can just put it over 1 and I have a fraction. And now I know, okay, I told you it's a proportion. These are two fractions that are equal. That means their cross products are equal. So I'll multiply 7 times x. I'll multiply 3 times 1. Of course, that's just 3. And then to solve for x, I'll divide both sides by 7. And that gives me the 1 here. And I have x. And I'll just leave it as a fraction. X is equal to 3/7. So there's that proportion. So another look at how things might look a little bit different, but you can still make proportions out of things by using the number 1 and the fact that the number 1 under a number has the same value as the number itself. Okay, let's take a look at 3 applied problems. So example 4. Okay, let's say here, you spent, this is where proportions really come in handy. You spent $27.68 to fill your, pardon me while I'm trying to read my other work over here, your 14-gallon car with gas. How much did you spend per gallon? Now we know from doing previous, let me stop a little bit. We know from we've done some previous word problems, kind of one-step word problems. We know we're going to find something that's per gallon. We know we're dealing with division. So one way to solve this is to say, okay, well, I spent, let's see here. I'll take my $27.68. I'll divide it by 14. Okay, I'm going to slip this over. Get my calculator in there, I think. Okay, let's see here. $27. Whoops, let's clear this first. $27.68. I'll divide it by 14, and I come up with $1.98. Remember, we deal in dollars and cents. A cent is 100th of a dollar, so I have to go by hundredths place. It's a 7. I looked to the right to the other 7, which pushes the first 7 up to an 8. And the answer here is $1.98 per gallon. So we know we can solve it that way. Let's take a look at it, solving it using proportions. Okay. We spent $27.68 for 14 gallons. Okay, that's the same as, we can set up a proportion, okay, how many dollars for 1 gallon? Okay, so we can set it up this way as well, depending upon what you find easier or finding what makes more sense. Notice that dollars are matched up with dollars, in this case in the same row, and gallons are matched up with gallons, again in this case in the same row. You have to match them up in order for the proportion to be accurate. Okay, so we have a proportion, and we know that when we have two fractions that are equivalent, we can cross multiply. So this is 14 times x. Whoops, tell you what, that's a little bit far away from what I've got going on here. X times 14 is 14. $27.68 times 1 is $27.68. Okay, whoops, I forgot the x. Sorry about that. And now I divide by 14 to solve by x by itself. And the x is going to equal to the same thing that I had over here, 27.68 divided by 14, and I already know the answer is $1.98. So a couple different ways to solve that particular problem. Okay, let me get another piece of paper. We'll do a couple more examples. Kind of more real life stuff here. Example 5. Okay, your 1,500 square foot house cost $175,000. Okay. What was the cost per square foot? Okay, so again, we can use proportions to solve this one. We can set up two equivalent fractions. I have a house that is 1,500 square feet, and the cost for that 1,500 square feet is $175,000. And I want to find out what is this, if I find the same relationship, but I want to know the cost. Okay, I put the cost down here because my cost over here is in my denominator, and I want to do it for 1 square foot. So once we've set up the proportion, we know we can use cross products. So this is $175,000 times 1 equals 1,500 times x. And we're back to a pattern we've seen before. Divide both sides by 1,500. In this case, that's a 1. And I'll skip a line because my 1 got a little long there. Let's see, I need my calculator for this. I got it in there? Yeah, I do have it in there. Okay. 175,000 divided by 1,500. Looks like it cost me $116.67 per square foot. $116.67 per square foot. All right, last example. Example number 6. You spent, whoops, hang on a second, I'm reading the wrong problem. Donuts, that's the problem I want. Donuts cost $10.95 per dozen. How much will you pay for 7 dozen? Okay, so let's take a look. We can look at solving this one as we did in example 4 in both ways. We know that if 1 dozen is this much and we're going to pay for 7, then the answer should be $10.95 times 7. Okay, let's take a look at what that is. $10.95 times 7, and we come up with $76.65. So that's one way to solve it, $76.65. We can also set up a proportion. Okay, so I know that it's $10.95 for 1 dozen donuts. Okay, so I'm going to set up an equivalent fraction because I want to find out what is the cost. Remember, dollars, if dollars start on the numerator in this case, I keep dollars in the numerator. How much is the cost for 7 dozen? And you can see, again, two fractions that are equivalent. If we use our cross products, well, x times 1 is x. And this gives us exactly what we had before, $10.95 times 7, which we already knew was $76.65. So a fair amount of work with proportions. They are, as I say, they are extremely popular. They are very useful for all kinds of things, medications, baking, all your cooking stuff deals in proportions and ratios. All kinds of like miles per gallon, miles per hour, those are all ratios. So there you have it.